On day 17, we looked at all the different cases with positive exponents, where our exponent was 1 or larger. So what happens if we have an exponent of 0 or an exponent that's negative? Those are the problems that we're going to explore today. So a couple of rules first. If a is not equal to 0, so your base cannot be a 0, then any other number for a, when it's raised to the 0 power, is equal to 1. With negative exponents, if you have an a and its exponent is negative, that is the same thing as 1 over a to the n. So it takes the base and moves it to the other side of the fraction bar. Also, if you have a fraction that's raised to the negative n power, the same way that the a moved from the numerator, because it was on the top here in our pantless fraction, it moved that a down to the denominator. It also would move a denominator up to the numerator. So a over b to the negative n is equal to b over a to the positive n. So when I first was taught about this, I had an instructor who described this as an elevator pass. Oops, which I can't spell evidently. Elevator, there we go, pass. So the way that he explained it was that when that number travels to the other side, when that base travels to the other side of the fraction bar, it loses its sign. That might make more sense as I start to do some examples here, but keep that idea of the elevator pass in mind as we go through these next problems. So first let's talk about the examples where the exponent is a 0. So our rule says that any number, as long as the base is not 0, when raised to the 0 power, is equal to 1. So 3 to the 0 power is going to be equal to 1. Negative 6 is not 0, so when raised to the 0 power, oops, I'm lying. It's only the 6 that's raised to the 0 power. So it is 1, and then the negative is applied afterward. This is the case where, because the negative is part of the number that's getting raised to the 0 power, that negative 4 to the 0 power is equal to 1. Here, the 2 to the 0 power is 1. We apply the negative. 2 to the 0 power is 1. We apply the negative, then multiply it by 4, giving us a negative 4. One more example here with these 0 powers. 4/3, because it's not 0, would still apply with this rule that when raised to the 0 power, it's going to be equal to 1. So 4/3 to the 0 power is 1. 3/4 to the 0 power is 1. When added together, they give us 2. Now let's look at our examples for these rules for negative exponents. Remember what I said about the elevator pass? So if we think of this fraction, or this number, this 3 to the negative 3, as being 3/1 to the negative 3, it's going to be the same thing as 1 over 3 cubed, or 1 over 27. Problem 27 looks more like our second example. We have 4/5 raised to the negative 3rd. So we're going to first rewrite that as 5/4 raised to the 3rd power, because those two changed places, so now that negative becomes a positive. And 5, when we cube it, is 125. 4 is 64. this 1/3. The elevator pass is going to cause these two numbers to switch places, so we end up with 3/1 to the second power, which is just 9. Here, our negative is going to travel, this outside negative is going to travel with us to the bottom half of this fraction. So we end up with 1 over -2 squared. But since -2, when it's squared, becomes positive, our final answer is 1/4. 3 to the -2. Again, notice the difference between this problem and this problem. Here, the negative sign is not connected to the 3 inside parentheses. So only the 3 with its -2 exponent are going to be moving to the denominator. So we still have the negative out front with the 3 getting squared. So this problem ends up equaling -1/9. In this last problem, we have a fraction where the numbers will change places. It becomes 5/2 getting squared. And because the negative is inside the parentheses, the negative is squared also. So we're going to end up with a positive 25/4 as our final answer.